Alright y'all, here's that video explaining the rest of the lab packet. This is going to cover all of the calculations. After day 1, the only calculations that you can do are 1, 2, and 3. After you figure out the mass of your weigh boat with the dry silver crystals, you won't get to do that till day 2. That'll be Friday. Then you can do the rest of the back page. Not all of the back page. I wonder if you're watching this on Thursday. I hope you are. Not all of this back page is going to be on the test. I mentioned that the test is going to be like lab related. None of this, so like percent yield is not going to be on there. This is not going to be on there. But 7, really just 7, I guess. So 4 and 7 are the questions that you haven't done yet that are fair game for the test, or at least that kind of thinking, not those questions specifically, obviously. Anyway, I'm going to jump in here. First thing, we need to find the molar masses of the substances that we used or were involved in this reaction. Remember the way we find molar mass? Molar mass, again, is the number of grams in 1 mole. The number of grams in 1 mole. And the unit for molar mass is grams per mole. That's how we write that out. The way we find it is by looking at our periodic table and adding up the atomic masses of all of the different atoms in the compound. So for AgNO3, I'm going to find Ag on the periodic table. That's silver. That has a mass of 107.87. To that, I'm going to add the mass of N, which is 14.01. And then I have 3 oxygens. Oxygen has a mass of 16. So 3 times that is 48. And now I can just add those up. 107.87 plus 14.01 plus 48. That gives us 169.88 grams per mole. Easy peasy. Copper, that's just straight from the periodic table. This is going to be 63.55 grams per mole. Silver, like we said earlier, that's 107.87 grams per mole. And then for copper nitrate, what we're going to have to do is we're going to have to take the 63.55 for copper. And the way that I'm going to do this is I'm going to notice that I have 2 nitrates. NO3 is nitrate. So I'm going to say 2 times, and then I'm going to add up the molar mass of a nitrate. So that's going to be 14.01 for my nitrogen, and again 3 oxygens, that's 48. So that's 2 times the mass of the nitrate. See what I'm doing there? So now I'll just add this up with my calculator. And I get 187.57 grams per mole. There we go. Okay, now next, use the molar mass of copper to calculate how many moles of copper were added to the test tube. The amount of copper that I put in my test tube was this amount, right? The copper wire before the reaction. That mass is 2.92 grams for me. Yours should be around 3, around the same. But if yours is smaller than that or bigger than that, that's fine. I know that some of the wires were bigger or smaller than that. So I'm going to take 2.92 grams. That's my starting number here. And I want to calculate how many moles of copper that is. So if we look at your periodic table, you should have written that in order to get from grams to moles of a substance, all we do is divide by the molar mass. So I'm going to divide by the molar mass of copper, which we already discovered up here, or we already wrote down, is 63.55 grams per mole. And now I can punch that into my calculator. 2.92 divide by 63.55. And that gives me 0.0459. I'm actually going to leave it like that, 459. If you did 0.5 or 0.46 Any way you round that's probably fine. But for clarity's sake, I'm going to stick with 3 numbers after my zeros, just to make it a little bit clearer what's going on. Next, how many grams of silver nitrate were used in the reaction? So I'm going to look at my data table, and I don't have anywhere the mass of just the silver nitrate. At least I don't have it in my data table, but I do have the mass of the vial of silver nitrate, which was 11.46 grams, and the mass of the empty vial, which is 9.71 grams. I can subtract those 2 numbers, and that'll give me the mass of my silver nitrate. So let me just do that real quick. 11.46 minus 9.71 gives me 1.75 grams. That's definitely more silver nitrate than you used. You probably used somewhere between 0.4 and like 1.2 grams of silver nitrate. But regardless of what you did, we can do the same gram to mole conversion, because again, I'm just going to use my periodic table to tell me that I divide by the molar mass. This time I'm going to use the molar mass of silver nitrate because that is the substance that I'm using here. So that's divide by 169.88 grams per mole. Punch that in my calculator. And I get 0.0103. Let's leave it like that. So now I know how many moles of copper I'm starting with and how many moles of silver nitrate I'm starting with. And that's great because number 3 is asking me, using this number of moles of AgNO3, fill in the rest of the BCA table to figure out how many moles of silver could have been produced. So all of a sudden, I have found myself back in the BCA tables that we were doing like 2 weeks ago, right? Where we were taking moles of reactant and trying to figure out how many moles of product we can make. So I just need to fill in everything in the right position. 0.459 moles of copper. That's how much copper I started with at the beginning of the reaction or before the reaction took place. Silver nitrate, we just said I had 0.0103 moles. Of course, I have no product before the reaction occurs, so that's 0 moles of each copper 2 nitrate and silver. Another thing here, you might not have caught this, but your chemical equation here is not balanced. I didn't give it to you balanced, so hopefully you caught that. I should have put blanks in there. That would have made it more clear. Sorry about that. But this is actually 2112. That's how this balances so that we are not breaking the law of conservation of mass. And now I can continue with my BCA table. So remember, when they give us, or when we have 2 quantities in the beginning, before the reaction takes place, when the problem gives us 2 mole amounts, what I have to do is I have to divide by the coefficient and then take the smaller one, right? So 0.0103 divided by its coefficient of 2 gives me 0.00515. Sorry about the small quantities here. I don't have infinite silver nitrate, so I can only give you a small amount. 0.459 divided by 1, because that's the coefficient here for the copper, gives me 0.459. I'm going to take the smaller number, which is this one, and I'm going to pull it up here to distribute all of my coefficients, distribute to each of my coefficients. That's going to give me my change row. This is going to tell me how many moles of reactant I use and how many moles of product I'm going to make. So 0.0515 times 2 gives me 0.0103 moles. That's how many moles of silver nitrate I'm using. I'm using all of the silver nitrate that I have. 0.0459. Oh, sorry. I gotta go. This is gonna be just times 1. right? This number times 1 gives me itself. I'm going to make that many moles of copper 2 nitrate. I'm going to make 0.0103 moles of silver. I'm not going to do the subtraction and addition because you can do that yourself. That's very simple. And I've already got my answer here. That's how much silver I can make, theoretically, right? I could have made 0.0103 moles, and hopefully I collected close to that. We'll have to see. My limiting reactant is, I mean, we can think about it from the point of view of the BCA table, right? We're using all of my AgNO3, so that must be the limiting reactant, my AgNO3. But you could also think at the end of your reaction, when you were done with your lab, or if you watched the video when I was done with the lab, what did we have left over? Did we have copper left over? Did we have silver nitrate left over? And pretty obviously, we had a bunch of copper left over. I added a whole 2.92 grams at the beginning, and at the end, I still had 2.60 grams left, right? So I still had a bunch of copper left over. So if the copper didn't run out, the copper can't be the limiting reactant. So that's just a little bit of logical thinking there. We don't even really need to use our BCA table for that. Anyway, there is that. You should have a number that is roughly half of that, I think, if you're using your own data, because you had roughly half the silver nitrate that I had. The common mistakes that I'm guessing you might have made if you did questions 1, 2, and 3 yourself is maybe not balancing your chemical equation, 2, 1, 1, 2, or maybe forgetting how to convert grams to moles. I hope that's not the case. Because we've been doing it for a while now. We've been doing it for, this is the second week. Is that true? Yeah, we've been doing it for 2 weeks now. So hopefully you're pretty solid on that. If not, you gotta do some more practice on that. There's definitely like YouTube videos you can look up converting mass to moles. There's millions of them out there, and it goes through the process very easily. Let's move on. Using your data, calculate the mass of silver produced by your reaction. I think this question could be worded better. I think maybe when I edit this for next year, it's going to say, using your data, calculate the mass of silver you collected or you were able to recover, because we might have produced more silver than we actually ended up collecting in the end. Just because of like lab techniques and human error and stuff, we could have lost some silver that we made. But we do need to calculate this number, because remember, the silver ends up in that weigh boat. And we didn't take the mass of silver itself, we took the mass of the silver in the weigh boat. So when the weigh boat was empty, it weighed 2.37 grams. With the silver, it weighed 3.45 grams. So I need to subtract those two numbers in order to get my mass of silver that I made. 1.08 grams is what I got. So that's how much silver I made. Again, you should have made somewhere in the ballpark of half of that, maybe half a gram. Then use the molar mass of silver to find out how many moles of silver did I actually collect. Right, how many actually ended up in my weigh boat. So I'm going to do my same calculation I've been doing, where I take the grams and I divide by the molar mass of silver. That's going to be 107.87. And when I do that math, I get 0.0100. So 1/100th of a mole of silver. Great. And how much did I want to make? Hey, that's pretty good. That's pretty good. So remember, like, this is the theoretical maximum that I could have made. I could have made 0.0103. So I'm pretty happy with that. That's pretty high percent yield. We're about to calculate that. Remember that percent yield is like a way to describe how close to perfection you are, I guess? Because look what we're doing. We're taking the moles of silver that we actually made. So in my case, I actually made 0.0100 moles of silver. That's how many I actually collected. And the BCA table tells me how many I could have made if I had reacted all of the silver nitrate that made it into my test tube, and if I had collected all of the silver that made it, that reacted. So that number is going to be right here, right? How much silver is technically possible to make with the amount of silver nitrate that I started with. So that's 0.103. Take a ratio of those two numbers and then divide by, multiply by 100. So I'm going to do that real quick. And yeah, this is pretty good. This is 97% yield. If you got significantly lower than that, I'm not surprised, okay, because you haven't done this reaction 20 times like I have, so you're not as practiced at it. But think to yourself, I'm actually not going to go through these ones because it's not important for the test at all. But it's interesting to think about like where your silver might have ended up. If you had some spillage, if you spilled some silver nitrate in between transferring from the vial to the test tube, or maybe if you spilled some silver nitrate solution once it was in the test tube, maybe some of your silver nitrate stayed on your copper coil. Maybe the reaction wasn't allowed to finish. Like maybe there's still some silver ions in the solution instead of as a crystal. That's some places that maybe you could have not made as much product as you wanted. If your percent yield is more than 100 and you are confused by that, because it's a little bit confusing, right? Somehow we must have recovered more silver than we started with. And we know that's not possible because of the law of conservation of mass, right? We cannot make silver crystals out of nothing. So if this is you, I don't think very many of you probably had percent yield more than 100. It is possible to have our data reflect that, but there's a couple of mistakes, a couple of sources of error that could cause our numbers to be like that. If you're really interested in why, come talk to me about that, because I don't really want to talk about it here, especially because I don't even know if any of you had percent yield more than 100. We can talk about that, just me and you. Number 7, my BCA table predicted how many moles of copper should have been spent by the reaction. So that's going to be this number, right? 0.00515 moles. That's how much I would spend if I spent all of this silver nitrate. If I spent all the silver nitrate that I had, then I would be doing the reaction this many times, or this many moles of times, which would mean that that's how many moles of copper I would use. But in reality, I did not use exactly that much copper, at least probably. I haven't done the math yet. How much copper did I use? Well, I started with this much, and in the end, I had this much left. So to get how much I used, all I need to do there is do subtraction, right? So subtract 292 minus 260, and that gives me 0.32 grams. That's how much copper I actually used. I actually used 0.32 grams of copper. How many moles is that? This is another gram to mole conversion. See, it's just the same thing over and over again. Grams to mole conversion, I'm going to take my 0.32 grams. I'm going to divide by the molar mass of copper, which is 63.55 grams per mole. That didn't work. Hold on. 0.32 divided by 63.55. Okay, so I actually spent 0.005. Let me do the correct number of decimals, 503. So I should have spent, or if I could have spent 515, and I actually spent 503. So that's pretty good. Again, I did not spend quite enough. But that makes sense because I was also a little bit short, right? I didn't make all of the silver that I could have. So I think what probably happened in my case was I did not let the reaction finish. I think I said in the video that I got a little bit impatient and I just wanted to move on with my day. So if I had let it sit for another 10 or 15 minutes, I probably could have gotten even closer to 100% error, maybe 99. But 97, I'm pretty happy with that. I'm pretty happy with that. But that's that. The test tomorrow, you're going to have to, I'm not going to give you like a data table with this and ask you to subtract numbers and stuff, but I am going to talk about different chemical reactions other than silver nitrate and copper. And I'm going to say like this many grams of something was made or this many moles of something was used, and ask you questions about other substances in that chemical reaction. Just honestly, quite simple stoichiometry problems. If this made sense to you, and if you've been doing okay on stoichiometry, this worksheet, where is it? This one, stoichiometry with molar mass. If you were good on this, you'll be good on the test. If you weren't good on this, try again. Look up some videos on BCA tables. I have some up, but they use molecules and not moles. The process is exactly the same. As far as like dividing this number by that number, multiplying by this, and I think we were all pretty good with the molecules. That was like 2 or 3 weeks ago at this point. Maybe go back and look at those videos. Go back and look at those packets that you should still have. And that will be helpful in preparing for the test. Also helpful in preparing for the test, like I said, gram to mole calculations, guys. Go on YouTube. Go on YouTube and just search mass to mole conversions. Just search mass to mole conversions practice problems or mole to mass conversions practice problems. There are a million videos out there. Please use your resources. You have the entirety of the internet at your fingertips. Lots of resources for you to use. So please don't show up tomorrow and be like, there was nothing to study. There's a million things to study, okay? You know what's been on the test. I've been telling you that the test is coming for like all week. So please study. Please do your homework. Please make it happen. Okay. Happy studying, and I will see you tomorrow.